Hello everyone. Today I'm going to show you how to apply the first, second, and the third normalized forms to our course students table. Um, Applying normalized forms are very important because it avoids lots of problems that might happen in the future, such as data redundancy, query complexity, and so on. So this is our original table, and as you can see, there are four columns. Enrolled students and grades columns are special here because um, these columns have multiple values, as you can see. Um, for each cell, there are more than one value, which is violation of the first normalized form. Also for the grades column, as you can see, EB, um, AEA, and so on. So as you can see, more than one value, multiple values for each cell that belongs to the column. It's the violation of the first normalized form. That's why we have to separate them. We have to separate these two columns into separate rows so that we can avoid violation of atomicity principle, and we can apply first normalized form. So let's apply it. We have to write our column names as it is. Course ID, let's just copy paste it. Yeah, as you can see, we copy pasted. Here it has to be enrolled student and grade because we will write one student and one grade for each cell. It's not gonna be students or grades. And for course ID, it will be the same. And for enrolled students, for example, as you can see, Nigar Kazimov and Nigar Hasanov both belong to biology and this course ID, and their grades are E and B. So we will write them separately, like C001 biology, Nigar Kazimova, E, and Farid Kazimov. Then again, C001 biology, Nigar Hasanov, B, Farid Kazimov. So we will write them separately, and let's do this and come back. So as you can see, we did it. Now we have separate enrolled, just 1 minute. Yes. Separate enrolled student and grade. Nigar Kazimova E, Nigar Hasanov B. As you can see, for each cell, we have only one value. For enrolled student column, we have only one value, Nigar Kazimova, Nigar Hasanov, and for grade, only one value for each cell, not multiple values, because it causes the violation of atomicity and first normalized form. So as you can see, we applied first normalized form, and now it's time to insert all this data, not manually, but automatically to PostgreSQL. And how we are going to do it, let me show you. So firstly, we have to create table. We will create table, which has name course students. It will have, as you can see, it will have 5 columns. Firstly, course ID. And its data type, I'll assign varchar because it's, as you can see, it's not int. It's C001, C002, and so on. So I'll just assign varchar, I don't know, maybe 50 or let's make it 200. And then secondly, course name. So again, varchar. Then enrolled student. then grade, and then professor. So now let's try to create the table. Yeah, as you can see, it returned successfully, and we can see our table here. So now it's time to import the data, but firstly we have to convert this Excel file to CSV file, and I'm gonna use um, a tool for this. So after applying first normalized form, now it's time to apply second normalized form. Um, to be able to apply second normalized form, we have to know several things. There are several rules that we have to follow. Firstly, our table should be already in the first normalized form, and we already applied it. Our table follows the rules of first normalized form. And the second rule is that there shouldn't be any partial dependency in our table, and partial dependency happens. So each table has a primary key, and in our table, uh, our primary key is a composite key because um, our primary key is course ID and enrolled student, the composition of it, because just by knowing course ID, we cannot uniquely identify the records. Therefore, we need another attribute, which is enrolled student. In other words, if we know course ID and enrolled student, we can uniquely identify every record in our table. So here we have 5 attributes, and a partial dependency happens when a non-primary attribute depends on only part of the primary key, but not completely. Like, for example, in our case, in our table, in course name and professor, they both can be guessed, can be found by just knowing course ID. If I know like course ID is C001, I can know that course name is biology. I can know that the professor is Ferit Kazimov. So by just knowing course ID, I can know course name and professor. That's why they are only dependent on course ID, but not enrolled student, which means that they are only dependent on the part of the primary key. So if we want to avoid it, we have to create separate tables, which are courses table and enrollments table. So now let's create them. Firstly, we are going to create courses table. Let's create it. So our courses table will include course ID attribute, and its data type will be varchar, and it will be primary key. Secondly, course name. Data type will be varchar again. And thirdly, we will add professor, and again varchar. So this is our course table. Let's create it. Courses table. Yeah, as you can see, it created the table. It returned successfully, and we can see it from here. Yeah, from here. So then we have to insert the data. Now it's time to insert the data. We will insert data that belongs to courses table from course students table. So how we are going to do it, let me show you. Insert into, we will write the name of the table, which is courses. We will write the attributes, which are course ID, course name, and professor. Later, we will write select distinct. select distinct the attributes that we want to insert, which are again course ID, course name, and professor. From the table, course students. So let's try to run the script. Yes, as you can see, it returned successfully. And if we look at the inside of the courses table, we will see all the data. Yeah, as you can see, here are all the data, course ID, course name, and professor. Now it's time to create our another table to achieve second normalized form, which is enrollments table. Let's create it. So our table will include our primary key, which is enrollment ID. It will be primary key. Secondly, it will include course ID. Course ID here will be a foreign key. Foreign key means foreign key is the key that has a reference to a primary key in another table. In our case, it's the courses table. So course ID, it will have varchar, data type varchar. Then we will have the rest of the attributes like enrolled student, grade, and professor we have in the courses table. So we will not write professor. So enrolled student. And grade. Yeah, as you can see, we wrote them. And now it's time to show SQL that course ID in our enrollments table is a foreign key. And let's show it. We will do it like this. We'll write foreign key, the name of the attribute, which is course ID, and references, courses, course ID. Yeah, we finally can create the enrollments table. Let's create it. Just 1 minute. Here there has to be a comma. As you can see, it created the table. We can see it from here, enrollments. So now it's time to insert the data inside it. And we are going to do it like this. Again, similarly to courses. Again, select distinct. Course ID. Enrolled student. Grade. From the table course students. So let's insert the data. Seems like there is a problem. Here, there must be a column. Not column, comma. So it created, it returned successfully. If we go inside of the enrollments table, we will see. Yeah, as you can see, there is all the data. Enrollment ID, course ID, enrolled student, and grade. So by doing this, we achieved second normalized form. So now it's time to apply third normalized form. If we look at the tables, to be able to apply third normalized form, we have to follow two rules. The first one is that the table should be in the second normalized form, and our table is already in the second normalized form, our tables, because we have two tables, courses and enrollments. And the second rule is that we should avoid transitive dependencies. Transitive dependency happens when a non-primary attribute depends on another non-primary attribute, which causes the transitive dependencies. And let's analyze if we have them in our tables or not. So our first table is courses table, and here we see two non-primary attributes, which are course name and professor. If we look at the course names, for example, biology, computer science, to be able to have transitive dependencies, they should, from the course name, we have to be able to guess the professor name. So biology gives us only one name, Farid Kazimov. So far, it's good. But if we look at the physics or psychology, it becomes complicated because the course name physics gives us three professor, or psychology gives us two professors. So which means from the course name, we cannot uniquely guess the professor name. So it's the same for the professor name. Just by knowing the professor name, we cannot know the course name because, for example, let's say Nigar Rahimova. From the professor name, we understand that the course name is physics, but there are lots of physics courses which have different course IDs. For example, C003, C007, C008. We don't know which one we are talking about. So that's why from the professor name, we cannot guess the course name. And when we look at the enrollments table, it's the same because we have enrolled student and grade. And from enrolled student, we cannot so if we look at the table, we will see that there are students which have the same names. For example, Nigar Hüseyinova, here and here. So if we say that the student name is Nigar Hüseyinova, it will give us more than one grade. One of them is A, one of them is C. So we will not be able to guess the grade. Or if we look at the grade side, F, we will see that there are lots of students whose grade is F, or maybe A. Let's look at A. Lots of students, this one, this one, this one. So we will not be able to guess neither grade nor enrolled student. That's why there is no any transitive dependencies, and that's why these tables, courses table and enrollments tables, are the final version. There are no any further steps that we can follow to achieve third normalized form, because our tables are already in the third normalized forms, because there is no any transitive dependencies. Thank you for listening. So now let's try to write our bonus assignment. Assume you have designed the tables in the first normalized form and third normalized form. We have already applied them in the first tasks. Populate the table, which is in the first normalized form, with the data in CSV. Let's try to do it. Actually, I have already done this, but just to show, we have to press import and export data. Then we have to import test.csv file. Yeah, I've already done this. I have already data in it. Then it says define a procedure to create tables in third normalized form according to your design in the database management system. So let's try to create the procedure. We have to create it in this way, or create or replace function. Then the name of the function, I will write create tables as the function name. And then returns void as $signs, and then begin and end. So, and at the end, it will be, $2 signs, language, and PLP GSQL. So we have to write our code, our queries between begin and end. Let's try to write them. I have already wrote the queries to create the tables, courses and enrollment. So I'll just copy paste them. Yeah, as you can see, I wrote the queries to create courses and enrollments tables between begin and end. Now I'll just run it to create the procedure. And as you can see, it created the function. It returned successfully. And now what it asks is to define individual procedure to copy the data from original table into each small tables. So if you have 3 tables, we'll have 3 procedures. In my case, I have 2 tables, so I'll have 2 procedures. So yeah, let's write the next procedures to copy the data. And it will be again create or replace function. Then the name of the function, it will be copy data into courses. Then returns, we already know these parts, begin and end. And finally, language, PLPG SQL. Yeah, we'll write our queries between begin and end again. I have already wrote insert query, so I'll just copy paste it again. Yeah, as you can see, I created 2 functions. The first function copied data into courses table. The second function copied data into enrollments table. And we have already wrote these queries, insert into courses, insert into enrollments. So we did this part for the first one. And now it says define another procedure called populate tables, which will call the previously defined procedures in a sequence. So let's do it. Create or replace function populate tables. And now we created a procedure whose name is populate tables. Now it says it has to call previously defined procedures in a sequence. So now, as you can see, I created populated tables procedure, and um, I wrote here firstly select, but if we are calling a procedure inside of a procedure, we have to write perform because otherwise it gives errors. So I wrote perform. And I'll select populate tables. So what will it do? It will create tables, copy data into courses, and then copy data into enrollments tables, which was what it asked from us. So we did it. I'll just run select populate tables, but I already did it. It did it actually, but let's delete them and try again. So now let's run. So as you can see, it created the populated tables. It called it, and let's refresh the tables. And as you can see, courses, enrollments, and let's look at inside of them. Let's see if it has inserted the data or not. As you can see, there is data in the courses table. And also in the enrollments table, there is data. So it worked. It created the tables, copied the data into courses and into enrollments tables, which was what it asked from us. Thank you for listening.